We're going to be doing inverses of square roots. It's going to feel kind of kind of redundant because we did it with quadratic. I'm just making things. It's going to be real redundant to the quadratics. So, and then also my poster over there, we're going to do it all four of those ways. We're going to look at it numerically, graphically, algebraically, and then we're going to prove them. So when you're looking at tables, the x and the y values are just going to switch. So the x values will become the y values will become the x values. So you just switch x and y for the table. Notation for inverse is this little -1. You read it as the inverse of f or f inverse. All right, so the little -1, it's not an exponent, it is the inverse. All right, so number 1, finding the inverse graphically. We're going to graph this just like we did yesterday. So first we're going to find the vertex, which is 3, 4. And the a value? 2. So I'm going to plot 3, 4. So 3, 4. And from my vertex, I'm going to go up 2 over 1, draw my square root. So 4, 6 is my other point. You don't need the other tail because it's not a cube root, it is just a square root. All right, now for finding the inverse, what am I going to do to those numbers? Switch them. So one point is going to be 4, 3 and 6, 4. All right, so I'm going to graph that 4, 3 and 6, 4. Now, if you remember from when we did inverses with quadratics, when you're graphing the original function and the inverse, it is always going to be reflected over the line y equals x. So this diagonal line right here, it'll be reflected over y equals x. And so your original and your inverse should match up. So your inverse is going to go like that. If your original crosses y equals x, so will your inverse, because otherwise it's not going to be able to be matched up, right? That only just makes sense. All right, so graphing that, does that make sense? Yes. It's because it's a positive number, it's going to be 2 real solutions. Negative number, 2 imaginary, 0, 4, 0. No, 0. When you, this whole thing is 36 minus 36. I mean, you just missed part of it. All right. For this part here is the inverse of function. So you do the pencil test, right? If your pencil only touches it at one spot, then yes, it is a function. So the inverse here, you take your pencil and you go along your function. If it only touches it once, then it's a function. So because it only touches the green line one time, it's a function. All right, for domain and range. So the domain of the original function, the yellow one, how far left do you go? What? How far left do you go on the yellow function? 3, good. And how far right? Uh-huh. And then for the range, how far down? 4, good. And then how far up? infinity. All right, so what's going to happen with the domain and the range of the inverse? It's going to switch, right. So your inverse is going to go from 4 to infinity, and then 3 to infinity for the range. All right, hop over to number 2 and do the same thing. All right, so I'm going to graph my vertex is at -5, -2, coming from those two numbers here. My A value is an understood 1 because of the very, very front number. So I'm going to plot -5, -2, and I'm going to go up 1 over 1, draw my root. So my points here, -5, -2, -4, -1. And then just like before, for the inverse, we are going to switch the x and the y. So -2, 5, -1, -4. And then plot it, -2, -5. Are you already done?
It was for Letterman fitting. She told us to go get lunch in the right way. It's 4 minutes. It's 5 minutes to go get lunch.
Okay. -1, -4 is the other one. And so I'm going to draw my inverse. So is the inverse a function? Yep. Yeah. All right, and then for the domain of the original, you're going left all the way to -5, right for forever. And for the range, you're going down to -2, and then up to forever. And then the inverse will just switch. -2 to infinity, and -5 to infinity. All right, so are we good with graphing and switching with the table? All right, cool. We're moving on to the algebra way. So finding inverses algebraically. All right, you're going to do this in 2 steps. First, you're going to interchange x and y, and then you are going to solve for y. So on number 3, you're going to make that y an x. You're going to make that x a y. And now we're going to solve for y. So we're going to move all of this stuff over here with the y over to the other side, so y is by itself. All right, so we're going to reverse PEMDAS. What are we adding or subtracting? The 1. So we're going to get rid of that first. All right, here you can't combine the x and the 1, so you just write it as x minus 1 equals 3y squared. Then what do? Divide by 3. Good. Multiply or divide. So you get x minus 1 is over 3. And then what? How do you get rid of the square? Square root. Very good. Every time you square root, you got to put a what?
Plus or minus.
A plus or minus sign. All right. Now, is the inverse a function? Because of this plus minus sign, when we are looking at the graph, this is a radical function, right? Square root, like dot and arrow. So when we're looking at the graph of this guy, you have the positive version, so the one on top, the dot and the arrow on top, and then the minus version as well, the dot and the arrow on bottom. So because you have both the positive and the negative, is it a function? No, because it will not pass the vertical line test. It hits it twice. Does that make sense? So anytime you get a plus minus, that's going to tell you it's not a function. Otherwise, it'll be a function. So the plus minus is what makes it not a function. Okay, number 4. Switch the x and the y. So this guy becomes a y. This guy becomes, this guy becomes an x. Hello. That guy becomes an x. This guy becomes a y. All right, now we're going to solve. The 2y minus 5 is underneath the house. So you cannot do anything with the 2y minus 5. You first have to get rid of the square root. So how are you going to get rid of a square root?
A math way.
I forgot.
You square it?
I was gonna say it, but I thought
No, you're right. Square it. So square and square root will cancel each other out. And so now you're just left with 2y minus 5. And then what do? Add 5. Okay, and then what? Divide by 2. And so your inverse is x squared plus 5 divided by 2. And is that guy a function?
Yes.
Yes. So the only time you're going to have not a function is if you get that plus minus. So yes, this is a function. Specifically, what kind of function is it?
Rational. What?
Look around the room. Which one is it? We've done it before. If it has a square. If it has a square. What did you say?
Quadratic.
Quadratic, yeah. Quadratic. It's a parabola. So if you have a square, it's a quadratic. Okay. Moving on to number 5. All right, number 5, we are going to switch the x and the y. So this is going to become x. That's going to become y. All right, so what's the first thing? Add the 3. All right, how do I get rid of the 4 over 7? By what? Very good, yeah. Multiply by 7 over 4, the reciprocal. So I'm going to multiply both sides by 7 over 4. So that guy goes away. I'm going to multiply my 7 over 4 out just to make it look a little bit neater. So I get 7 over 4x plus 21 over 4. Does that make sense? Mm-hmm. Okay. All right, and then how do you get rid of the square? Square root. Mm-hmm. Square root. Every time you square root, you got to put a plus or minus. So since you have the plus or minus, is it a function?
Nope.
No. All right, do the algebra ways make sense? All right, just 2 more problems to do. So flip it over on the back. We're going to skip 6 through 8. They're just the same thing, doing the inverse. We're going to skip 6 through 8. And we're going to jump down here to the composing. All right, so for composing a function, that is the rule where if you put f of x into g of x and everything cancels and you get x, and if you put g into f and everything cancels and you get x, then they are inverses. Yeah, we've done it before. Yeah, we have. It should be it's kind of weird because we did inverses with quadratics, and the inverse of a quadratic is a square root, and now we're talking about inverses of square roots, which is a quadratic. So they're kind of the same thing. All right, so we are just going to test and see if these are inverses or not. So I'm going to take one of my functions, I'm going to plug it in to the other function. So I'm going to take f, I'm going to plug it into the g. All right, when you're plugging it in, go from left to right and just write what you have. So what is the first thing you see before the 5? The square root. So I got square root first. What comes after the square root? 5. Now in place of the x, what are you going to put? Very good. X squared. You might not have a calculator. And then plus 6. And now you're just going to see if everything cancels. So what is the first thing that cancels here? Not the 6s, because this 6 is being divided by 5 right now. The 5s. This 5 on top, this 5 on bottom will cancel. And so now you get x squared minus 6 plus 6. Now it cancels. The 6s. So you get the square root of x squared. Now it cancels.
The square.
Square and square. So you're just left with x. So yay, that one works.
No, I'm not going to work out that perfectly, are they?
Mm-hmm.
Now we gotta put the G in.
Right, so now we got to do it the other way. So now we're going to put g into f. All right, so now we're writing the f equation. Instead of the x, though, what are you going to put? Right, square root of 5x plus 6. All right, what comes after the x? Before that? The squared. What comes after the square? Minus 6, and it's all over. Mm-hmm. And then you're going to see if everything cancels. So what do you notice cancels first? The square root and the square. And you're left with 5x plus 6 minus 6. The 6's cancel. And you're left with 5x over 5. The 5. And so you're just left with x. So since both of them work, then yes, they are inverses. So yes, inverses. Okay. Jump over here to 10. Alright, so we're going to do the same thing. We are going to take G. I'm going to put it in to H. So I'm writing the H one. So what's the first thing you see?
The square root.
The square root. What comes right after the square root? 3. And then in place of the x, we're going to put what? Good. And then after the x. Okay. Can you cancel these 2's out? Think.
Don't you have to do the 3's first?
Right, you have to do the 3 first. So order of operations says you have to multiply before you can add or subtract. So we have to multiply this 3. Now this 3 is being multiplying all of this. So you are going to multiply it by the x squared term and the 2. Does that make sense? You just distribute it, okay?
So it's just 1x squared?
Right, so 1x squared and 3 times 2. 6. And what's 6 minus 2? 4. So are things canceling on this one?
No.
No. So this one is not working. So that means that they are not inverses.
So if it's like notify us when we don't got to do the second.
Right. So the first one's no. You don't even have to worry about the second one. This right here, the distributing, is what's going to get what they're going to try to trick you on problems like these. All right. So everything's going to work out and be nice and they'll cancel, or they'll try to trick you on a multiplying where it is not actually going to work out. So when you're proving, all you got to do is put one in the other, see if everything cancels. Questions? Sweet.